Hello everyone, my name is Arpit Gupta and in this assignment we are working on SAS Enterprise Miner to build a neural network model. So before we do any further analysis, let's see how our dataset looks like. This is an admission predict which I have taken from Kaggle. It has various attributes like GRE, TOEFL, University, SOP, LOR, CGPA and research, and a target variable is chance of admit. So this data has 500 counts and for that we are here to analyze the chances of predict based on the scores of 500 students, and let's see how our SAS miner is used to build the neural network model. So here I've imported the file, and to do a quick start explore I've used the stat explore here as well. So let's see the result of it. As you can see, the correlation among the variables and the variable worth, which where CGP has given more worth. And for a concept one, I need to tell you that here the missing values are there are no missing values, but in case of missing values we could use imputation, that is the replacing null values or missing values with central tendency like mean median mode to do a better analysis. But here we don't have it, so it's perfectly fine for us, and we can see that CGP has more correlation among the variables. And for my concept 2, here you can see I've partitioned my data set. Why I did that? Because if I've taken my complete data set on training, it would lead to generalization, that is overfitting. So that is why I've split it into a 75% training and 15% validation and 10% test to avoid overfitting. So it will be better to predict future values. I've taken control point to build multiple neural network models, and here is my neural network model 1. And for that I've taken as a multi-layer perceptron architecture with 4 hidden units to increase the complexity. And optimization, I've taken a back propagation training technique and 25 iterations. I've kept my learning rate high and momentum low, which is an ideal scenario. So let's analyze this neural network model, which will be a concept 3. So to see the this neural network model 1, we can see it works well for the training data set, but it's not working fine for the validation set. And after here in this plot you can see that after 11 iteration it found a good number of variables that would work. Then it continued to optimize. We can't see it, but probably because it really got worse and worse in terms of predicting data set, that so probably is overtraining. And here you can see that it actually used 41 weighted variables. So it's quite not a bit more, but to avoid the complexity we could drop certain variables and use potential variables to decrease the weighted to decrease the weights. And we are more interested in the average error function. Here you can see the average error function is this 0.0047. And let's see a second neural network model. Here I've only made one change, is that in optimization I've used a default, rest I've kept the same. So let's see the result for this one. And here you can see that after 2 iterations it found a good number of variables that would work, and then it continued to optimize, but probably more variables into the model really got worse and worse in terms of predicting data set that I didn't see. So it's probably overtraining. And in this we can see for trained data set work fine, for validate not so good. And again 41 weighted variables are used. And it's now to compare both models, I've used a model comparison, which will be my concept 4. And let's see the result for model comparison. And FA statistics tells us that neural network 2 perform well on our data set, and as you can see the average squared error for this one is less. And also you can compare the graphs for both the models. So neural network 2 performed well on this data set, but also not quite so good. So this was a whole analysis. What I learned from my data set using neural network is it would be better if I use regression, because it's neural network works well on classification problems and to classify from A to B, and it works well. For a regression like problem, it's certainly they are good to train, but then it leads to overfitting. And that's the whole analysis. Thank you.